Okay, in this video I'm going to pick up where I left off and try to wrap up the worksheet for today. Number 5, imagine that you invested $100,000 in an account. Well, again, you're starting with $100,000, so there's our principal or our starting amount. 5.9% annual interest, so there's our R value. Make sure to report that as a decimal after moving that decimal point. This interest is compounded monthly, so we know that our end value is 12, and we want to know what the ending balance or ending amount is after 18 years' time. So we've got a P, R, N, and T value. All that's missing is A. And since all we need is A, then it should be relatively easy to solve once we make our substitutions. I went ahead and wrote that down off screen here. Um, and I think this would be awfully nice to have $100,000 that we can invest one time and walk away from. It's pretty atypical that people have a large sum of money that they can invest this way. So tomorrow's video, we're going to revisit this notion of periodic investments, where you invest small amounts frequently and see what they're worth after the long run. But in this particular case, with $100,000 set aside at 5.9% interest, well, we'll again walk through the process that we've seen 2 times already in this series of videos. In the innermost parentheses, I'll take the 0.059 and divide it by 12. Then I will add 1 to that. And of course, in between all of these steps, I'm just pressing the equal sign, but I'm not clearing my calculator. This decimal is the result for the innermost parentheses, so I need to raise that to a power. Now the power is the result of 12 times 18. So I'm using my parentheses to complete that computation. And when I press enter, we have the inner parentheses raised to this power, and this growth factor needs to be multiplied by 100,000. So after 18 years' time, a long time to walk away, the $100,000 has turned into a $288,000 net result. And again, while it's a bit unusual to have $100,000 that you can walk away from for 18 years, a lot of times this computation is a good way to estimate what your house might be worth after owning it for a certain amount of time. If you had bought a house that was worth $100,000 and real estate prices in your area were growing by 5.9% per year, then after 18 years' time, after living in that house for 18 years, your $100,000 home, in a sense, might be worth, or approximately worth, $288,000. So that's another way to think about this particular problem. With number 6, Danielle has a CD at this particular bank. CD stands for Certificate of Deposit. She invests $22,000, so that sounds like a starting amount, principal. For 4 years' time, that sounds like a T value. At 4.5% interest, so I think our R value ought to be 0.0455. And we're compounding our interest monthly, so our N value is 12. Most of the time in the real world, we do use an N value of 12. So our objective here is to find her ending balance, which is our ending amount, our A value, and also to calculate how much interest she earned. And that's going to be the same style of question that we saw back here in number 4. So pause the video now and try this one on your own. Resume playback in a moment to see my work. Okay, so in the same method as we've used in the past, I've simply substituted the appropriate values into their positions in the formula. And when using my calculator, again, simple calculator going from the innermost parentheses and working my way out, ended up with $26,802. So the investment started at $22,000 and it ended at $26,000. It grew by a total of $4,452. So we have an ending balance or ending amount of 26,000 and a growth of interest of 4,400. So this last question is particularly interesting because we've got two scenarios. In both scenarios, you're investing $5,000 and you're investing for 10 years' time. In one scenario, you're compounding your interest daily at 6%, and in another scenario, you're compounding semi-annually or twice per year at 6%. So all being the same except for how often the interest is compounded. So we would like to know, what's the difference between the two? And this is particularly interesting because if you were to start investing, especially if you leave your money with a bank in a CD, you can actually shop around and find what different banks are doing. If one bank offers you interest compounded daily, and another bank offers you interest compounded semi-annually, and the terms might be just a little bit different, you should be able to do the math and determine which one's going to be best for you, which one's going to produce the most amount of money in the long run. So I'm going to pause this video here, and I suggest that you do the same, and I'm going to set up both of these computations. I'm going to do the daily computation on the left and the semi-annual on the right. So here's the setup for each. On the left, you can see that we are compounding our interest 365 times a year or daily. And on the right, we're compounding our interest only 2 times a year or semi-annually. And so now the question becomes which one's going to be worth more and how much more. So again, I suggest you pausing the video and trying these computations on your own and see what result that you achieve. And here we can see that by compounding our interest daily, we end up with a total balance or ending amount of $9,110.14, whereas semi-annually we only end up with $9,030.56. When we subtract the two, we can see that there's a difference of $79.58 in favor of the daily computation. And so again, it's a bit interesting to see the difference in results here. This person did start with $5,000 and ended up with $9,000 in either case. It did take 10 years to get there, but the daily compounding interest did return a little bit more. So hopefully this series of practice problems helps you understand the content just a little bit better. If you have any questions, please let me know, and you can reach out to me through Schoology or through email. Thanks for watching.